Yesterday's gone. All right. So let's take a look at coordinate geometry, right? So if I give you something like this, right? Let's say I gave you 2 points. 1 point is A and 1 point is B. A is x1, y1, and B is x2, y2. So it's just like 2 random points. Let's say I gave you 2 random points. There are a few things that you could find. The first thing you could find is the what? Right in the middle, we could find the midpoint. The second thing we could do is find the length of the line. Third thing we could do is what? Find the gradient, right? We could find gradient. And the next thing we could do is find the equation of the line. All right? So those are some of the things that we could do with those 2 points. In order to do that, you have to know these formulas, right? So the first formula you have to know is midpoint. Right? To find the midpoint, you add up the 2x values, divide by 2, add up the 2y values, divide by 2. Okay? To find distance between 2 points, you find the square root of x2 minus x1 squared plus y2 minus y1 squared. Right? To find gradient, y2 minus y1 over x2 minus x1. Okay? And last thing, to find the equation of a line, right? We'll spend some time on this. To find the equation of a line, we could use this formula here. Y minus y1 is equal to m by x minus x1. All right, copy down the rules. Copy down the rules. Let's see what we could do from there. That's it. X2 minus x1, right? The x2 first in its distance. And y2 minus y1 and so on. Yesterday's gone. All right, so we're starting with the easy part today. Hopefully. I get a little tough in there. Are you writing? Finish? Imran, finish? All right, waiting on you. All right, actually, while we write here, let's try to find the midpoint, the distance AB, and the gradient, right? I'm gonna give you some values, right? Let's say this value here is 3, 2, and this value here is 7, 8. Morning. Right? 3, 2, and 7, 8. Let's see if we could just take the values, plug it in the formula, and get the answer. Ignore this one, right? Just find the midpoint, distance, gradient. Let's just see what you got now. All right, in here in the dark blue, right? So you can see that x2 is 7, y2 is 8, x1 is 3, y1 is 2. So to find midpoint, we just going to plug this in the formula. So that'll be 7 plus 3 over 2 and 8 plus 2 over 2. So that's what? 5, 5? Yeah? 5, 5? Are you okay with that? That easy, right? Right? Question, does it matter which one you pick for x1 and y1? So suppose you pick x1, y1 as top. Does it make a difference? No, it don't make a difference, right? So if you choose the top as x1, y1 and the bottom as x2, y2, right? It should be okay, right? I just saying preparing here, boy. Anybody could just check on the live once it's working. Check on the live once it's working. Right, next one, distance. Distance is the square root of x2, which is 7 minus 3 all squared, 8 minus 2 all squared. That's the square root of what? Remember, we did surds, right? So let's see if we could break it up. That's the square root of 4 squared, which is 16, 6 squared, which is 36. So that's the square root of 52. Can we break it down in terms of surds? Can we write 52 in terms of surds? I think so. We could. Try it and see. Break down root 52 in terms of surds. Try it quick. Of course, yeah, you have to figure out 52. Again. Okay. You have to write 52 as a product of a perfect square, right? So write root 52, come on. Okay, so 52 is what? 4 multiplied by 13, correct? So that'll be root 4, root 13, which is 2 root 13. Correct? Right? So you can simplify in terms of surds, right? Anybody got that? Okay, nice. And gradient is what? Gradient is 8 minus 2 over 7 minus 3. So that's 6 and 4. That's okay? All right. So those are the simple things that we have to be able to do, right? Any questions on that so far? Yeah. So the next thing you want to do is find the equation of the line. I forgot to mention that the symbol for gradient is m, right? But let's make a note of that. The symbol for gradient is small m, right? Common lowercase m. It's lowercase m. Nice. Let's quickly find the equation of a line. To find the equation of a line, a line always looks like this, right? There are different types of lines. You have a line like this, You have a line like this. You have a line like this. And you have a line probably like this, right? Those are the three general shapes for a line. What do we need to know about a line? Well, we need to know how the line is sloped. This is called a positive slope. So the gradient is positive. This one here is a negative slope. So the gradient there is negative. All right? So if you have to go up the hill, positive slope. Down the hill, negative slope. So anytime you work out the gradient of a line like that, it's positive. In P, gradient there is negative. In C, this has no gradient. And in D, this has a gradient of infinity. All right? So each one of those have a different equation of a line. It will look different. So for example, the first one, it will look like this. Y is equal to positive mx plus c. Next one will look like this. Y is equal to minus mx plus c. Third, there's no gradient, right? There's no gradient, so the equation is, what's the equation? If the general form for equation is y is mx plus c, what do you think will be the gradient? Sorry, what do you think will be the equation for example C? Yeah, y equal C, correct, because it has no gradient. Y equals C. How about the next one? What about D? Gradient. Y equals to infinity. Sort of, but that's not really an equation. So the way to write it is this: x equal to some value. So let's call it k. So if this line passing through x is 4, the equation is x is 4. Okay? Okay. So once you see a line, you should be able to kind of have an idea of what it might look like, right? What the equation might look like. Okay. Right. It's also important that you could identify a line by its gradient, right? Am I right, Insel? Finish him run. Okay, last one. Yesterday. Okay. All right, let's go back to that first one now. Just remind me of the coordinates, please. The first one was what? 2, 3, 3, 2, and 7, 8. Right. So let's find the equation here. Right, 3, 2, 7, 8. Right. So in order for us to find the equation, all we need to do is use this formula. Y minus y1 is m by x minus x1. It doesn't matter which point you choose for x1 and y1, right? But initially we choose here. So you have to be consistent with what you have, right? So therefore we know the gradient. The gradient was what? 3 on 2? 6 on 4? 3 on 2, right? What's the gradient? 3 on 2. What was x1? X1 was 3, y1 was 2. So all we're gonna do now is take each one and plug it up there. All right? So when we substitute, it'll look like this. Y minus y1 is equal to 3 on 2 by x minus x1. That's one method you could use. The next method is like what we did in maths. Find the y-intercept and put it back in there. Anyone could work. So you'll get y minus 2 is 3 on 2x minus 3 on 2 by 3 is 9 on 2. Right? Carry across the minus 2. Right? And you'll get 3 on 2x minus 9 on 2 plus 2. We don't really like the fraction, so multiply everything by 2. So you'll get 2y is equal to 3x minus 9 plus 4, and you wrap it up here. 2y is equal to 3x minus 5. You have a nice equation there, no fractions. Okay? Finish? Let's go again. Right in. Go ahead. Let's try one like this. Oh, by the way, if you had an equation looking like this and you wanted to find the gradient, always remember, for you to read off the gradient, you can't just have the equation like this and then say whatever in front of x is gradient. You can't do that. You have to always make sure that the value here is 1. So the only way you could do that is to divide the equation by 2. And then when the equation in this form, you could say the gradient is 3 on 2 and the y-intercept is c. Okay? Remember those small things, right? Let's do one more before I give you some rules on gradient. So I'll give you 2 points, same thing, A and B. What's your slope? So you should have an idea of what type of gradient it will look like. Right? Let's say here is 1, 7, and here is 8, 2. Try that, find the equation. No, just the equation of the line. Just the equation of the line. All right, let's see what you got. So let's start with gradient. Would it be positive or negative? This gradient should be what? Negative, right? So I will choose 7 as y2 minus that, 1 minus 8, right? So that's minus 5. Sorry, that's positive 5 over minus 7. Okay? And then we're going to use the formula y minus y1 is equal to m by x minus x1. So that's y minus y1. Remember, I use this as my x1 and y1, right? So that's y minus 2 is minus 517 by x minus 8. Right? So you'll get y minus 2 is equal to minus 517 by x plus 5 by 8 is 40 on 7. Multiply everything by 7. 7y minus 14 is minus 5x plus 40. Right? Bring everything on one side. 40 plus 40. 7y is minus 5x plus 54. Right? Let's check out how the answers went there. Anybody got that? After you multiply it out, check and see if I multiply wrong. Huh? Hold on. Yes, it is. Anybody got that? Yeah? Check it back and make sure. So you make a mistake. You all had up until here. Yeah? Right. So probably you make a mistake with dealing with the fractions, right? So we don't want to have to deal with fractions too often. Right? So what you want to do is get rid of it as early as possible. And the best way to get rid of fractions is multiplying every term by the denominator. All right? Online, any questions there? Chloe? You got it? Okay. Let's try one more. Any questions? Everyone? Right, the key is simplifying it nicely because you see this here? More than likely, you'll have to use that later on. Right? But you follow it now, Chloe? Right? The key is when you reach here, you need to get to here, because when you have to solve simultaneously, you'll need an equation looking like that. You don't want to have to work with the one with the fraction. So are we leaving the 7? Yeah. No, leave it 7y. Leave it just like this. There's nothing to solve. Right? The objective was to find the equation of the line, and that is the equation of the line. Let's try our next one. I'll pass along and watch it, right? All right, let's try this next one here. Try that there. Right, try and make it look nice, right? Try and simplify it all the way out. All right, let's see how it went. I just saw one or two small little mistakes, right? Let's start with the gradient. Remember with the gradient, you want the y2. So your y2 is 8x. Y1 is 4, right? So it's 8 minus 4, 16 minus 10. So your gradient is equal to 4 and 6. You can simplify it to 2 and 3. Right? It don't matter. You can leave it as 4 and 6 if you want as well. Right? I will leave it as 4 and 6 because I saw plenty of people did it like that, right? And then we're going to substitute in y minus y1 is m by x minus x1. So that will be y minus y1 is 4. Gradient is 4 and 6 by x minus 10. Right? If you want right there, you can multiply by 6, up to you. Or you can go one more line and then multiply by 6. So y minus 4 is 4 and 6x minus, remember, when you're multiplying 4 and 6 by 10, right? It's like saying 10 on 1, eh? So 4 by 10, that's 40. 6 by 1 is 6, right? So you don't want to make those simple mistakes and lose marks, right? And now you have your fractions. Multiply everything by 6. You'll get 6y minus 24 is 4x minus 40, right? Right, remember, I wanted to understand the reason we're doing that, right? The reason we're doing that, you don't want to work with the fractions. So to make it simple, you multiply every term. And remember, this should be every term, right? Now you have something much easier to solve. So 6y is equal to 4x minus 40 plus 24, right? So your final answer will be 6y is equal to 4x minus 16. Yeah? Online, you're good at? I saw one answer, Eden. Very good. Anybody else got that? Hamlet, you there? All right, good job, Bash. Right, again, that's one option. Some people may have, because they use 3 and 2, you may have, if I divide this by 3, sorry, by 2, you'll get 3y is equal to 2x minus 8. Okay, so it could also look like that. Right, 3y is 2x minus 8. You okay with that? Are you okay with that? So you want to add on, you all remember the rules of gradient. If you have parallel lines, gradients are what? Equal. And if you have perpendicular lines, gradients are minus 1 on them, right? Negative reciprocal. Okay, so we have rules for gradient. Right, just some quick rules. Rule 1, if you have parallel lines, right? If the lines are parallel and you have gradient 1 and gradient 2, both gradients are equal. If you have perpendicular lines, gradient 1, gradient 2. If you have perpendicular lines, the product of M1 and M2 is minus 1. Okay? The product of M1 and M2 is minus 1. Add master. Ready? Right, quick example here in red. If the gradient here is 2, then the gradient here is 2, right? Real simple. It can't get simpler than that, right? Okay? But suppose the gradient here is a half, right? Then the gradient for the perpendicular line is negative reciprocal. That's the easiest way to find it. Negative reciprocal means flip the value over and change the sign. Okay? Flip the value over and change the sign. Suppose the gradient was negative 3 on 2. The perpendicular line is what? Flip the value over and change the sign. Okay? This is called negative reciprocal, right? Flag on spell arrow. Right? Flip the value and change the sign, right? So change the sign and flip the value. So I'm gonna combine all that now. Right? What does perpendicular bisector mean? What does perpendicular bisector mean? It means that it's perpendicular to the line and it cutting the line in half, passing through the midpoint, right? So, anybody writing? So if I ask you for the perpendicular bisector of a line, right? Let's say I gave you this line AB, and I want you to find the perpendicular bisector. First thing you need to do is get a midpoint. Let's say the midpoint is C. And then draw a line through that. That's 90 degrees. Right? That's the perpendicular bisector of AB. So number one passes through the midpoint. Number two, perpendicular to the line. Okay, so those are the two important things that we need to know about the perpendicular bisector. Now we're going to throw in it deep and see if we can find the equation of that line. I'll give you some information just now. Right? Any questions online? Isaiah? You okay? Hamlet? Are you there, Hamlet? Hamlet? You there? Okay. Isaiah? Again, sure?
Yes, sir.
Okay, nice. Right, so here's what I'm going to do now. I am going to give you A and B. And I am going to ask you to find the equation of that perpendicular bisector. Right? So for you to get the equation of the perpendicular bisector, you have to get two things. You have to get the midpoint of the line and the gradient of the perpendicular line. Okay? So you have two things to get, the midpoint and the gradient. Once you get that, then you can go back and use the formula from before. Anyone includes? No matter. Doesn't matter which one. Yesterday's gone. Let's go. How are we gonna do this now? I'll leave it here. I'll give you 2 minutes. Let's see what you come up with. So I want you to find the equation of the perpendicular bisector of, I'll just draw a random line, right? A, right? A is 1, 4, and B is 3, 5. Right? Find the equation of that perpendicular bisector. So you're trying to find the equation of the line that will cut it through the midpoint and perpendicular. Go ahead. Follow the steps and try that tomorrow. What's the first step, Imran? Find the What's the first step in finding the equation of the perpendicular bisector? Find the midpoint. Then the second step is what? And then use the formula, right? Right, let's check it out here, right, Tolia? Hamlet, Cleo, you could also send the points, right? You could send the points something in the meantime. So the first thing I'll do is get the midpoint, right? I'll add up the x values, add up the y values, and divide by 2. Right? And then I'll get the gradient. The gradient is 5 minus 4 over 3 minus 1. So that's 1 on 2. But we need the gradient of the perpendicular bisector. So the gradient for that will be flip the value over and change the sign. Negative reciprocal. Right? And now we're going to use y minus y1 is m by x minus x1. Please remember that this y1 and this x1 has to be the midpoint, because the midpoint is where the line passing through. You can't use here and you can't use here. You have to use the point that the line passes through. Okay? So we'll end up with y minus y1. y1 is here, 4.5 is equal to gradient, which is minus 2 by x minus x1. x1 is 2. So you'll get y minus 4.5 is minus 2x plus 4. Carry across the minus 4.5. And you'll get 4 plus 4.5. So you'll get minus 2x plus 8.5. Some people may have multiplied everything by 2, and you would have gotten 2y minus 4x plus 17. Either one could work. Okay, nice. Good job, Amrit. Good job, Amrit. Let me see what else we have online here. Good job, Jason. And right, good. Right, Venetia, your mistake was you used the wrong point, right? Right, remember you can only use the point on the line. Okay? Let's do one more wrap up. Right? Next day we'll add on the circle part of it now and then do some past papers. Oh, I want to send you a solvent simultaneous in the group, a kind of hardish one. Right? You have to use substitution method. Right, let's try one more. Last one here, Olio. 2 minutes. Let's see how fast we can do it. Find the perpendicular bisector, right? Find the equation of perpendicular bisector. I'd work it out fast, message answer. Last minute. Finish this up. Finish. All right, so let's check it out. First thing, let's find the midpoint. So that's 7 minus 5 over 6 minus 4. So that's 2 and 2. So that's 1. Sorry, I find the wrong thing. I found gradient. So therefore, the perpendicular gradient is equal to -1, right? If you flip 1 over, you'll get 1. Okay? So the gradient is -1, right? Second thing, find the midpoint. The midpoint is 7 plus 5. Yeah, do the x first, right? The midpoint is 4 plus 6 on 2, 7 plus 5 on 2. So that's 5. So that's 5, 6. 5, 6. Okay? That's 5, 6. So now we're going to use y minus y1 is m by x minus x1. So that's y minus 6 is equal to -1 by x minus 5. So y minus 6 is minus x plus 5 carry across the minus 6, you'll get minus x plus 5 plus 6. Minus x plus 11. That's it. That is it. Okay? All right, so please don't forget these things, right? Next week, what we'll do is we will continue from here, right? I'll give you